So let's go through some advanced level subnetting. So imagine if we want to create, in that example, 100 subnets. So for 100 subnets, if we have 6 bits, this will give us only 64 subnets, so we need 7 bits. So in that case, we need to borrow 7 bits, and in that case, the network address, remember, it's 172.16.0.0/16. This is also another range of private IP addresses. So we need to borrow 7 bits, as we can see here, and the rest will be the host portion. So in that case, 7 bits will give us 128 subnets, and for each subnet we have 0 and then 8 bits. So the 8 bits will give us 256 different addresses, and if we have another bit, this will double that number, so will give us 2 to the power 9 minus 2. So 2 to the power 9 is 512, so this will give us for each subnet 510 host addresses for each of the 128 subnets. So let's see, this calculation here shows how we can. So remember, if we borrow 7 bits from the 16, so 7 plus 16, so this the new subnets will be /23, which means that the last byte and 1 bit from the third byte will be for the host portion, and the network will be /23. So in that case, the first subnetwork address will be 172.16.0.0/23, and the next one is to set this bit to 1. The range of the host addresses is to increment this by 1, and then to set all the bits to 1 except this bit, and this will be 172.16.1, and then /255 or 254, which is 255 minus 1, and this will be /23. And of course, the broadcast address will be 172.16.1.255. So it's exactly the same like what we did before, but this is more advanced or more complicated using a different number of subnets. So this example here shows another range of private IP addresses. In that case, it's actually 10.0.0.0/8. So if we need 1024 different subnets, and in that case we need to borrow from the host portion, we need to borrow 10 different bits. So we borrow all the 8 bits from this byte and 2 bits from this byte. So this will give us here 10 dot all zeros and then 2 zeros in this byte, and then the rest will be zeros. So if we borrow 10 bits plus 8, that's /18. So this network will have a subnet prefix of /18. So in that case, this example here shows the subnetwork addresses. So the first subnet will be to set the subnet number to zeros, and then the second subnet will be to set it to 1, and this number, remember, is 10.0.64.0, as we can see here, and then this one will be 11, which means 10.0.192.0. Actually, there is one before that, which is 10.0.10 and then all zeros. So 10, this is 128, and then 0, and so on. So this is 11, and we keep doing that for all the 1024 different subnetworks. So let's go through some activities again. So here the network address portion will be again to include this number here until the subnetwork mask, which will give us here network addresses 0000, 1010, 01111, 00, and then here we have to be careful because the subnet mask is 66 bits, and then the rest will be zeros. So those 6 bits will remain the same, which will make it 1 1 1 1 0 0, and then the rest will be zeros, and then the rest will be all zeros. All right. So remember that this number is simply the same number here minus 1. So this will be 240 because we only set this bit to 0. So this is 240, and the rest will be the same. This is 10, and this is of course 0. So this number should be correct. All right. You can try a new number. All right. So again, the subnet mask here is 5 ones, and then there is 0. So this will be 1 0 1 0 1 1 0 0 0 0 0 1 1 0 0 1. And here we have to be careful. So these 3 binary bits will be set to 0. So 0 0 0 1 0, and then 0 0 0, and then the rest is zeros. Remember that this is 7. This is number 7. So all we need to do is just to subtract 7 from here. Or we know that this is actually number 16 here. So this is actually 16, and the rest will be the same. And of course, this is 0. See? All right. So this is correct. Okay. So moving on to the next activity here. We just need the number of valid hosts. So we'll take all the subnet mask, and here we have only 2 bits for host. So this will give us 4 minus 2, which is 2. Okay, so that's an easy example. But let's take another complicated exercise. So here we have 4 bits and then 8. 4 and 8 is 12. So this will give us 2 to the power 12 minus 2. So we know that 9 bits will give us 512. 10 will give us 1024. 11 will give us 2048, and 12 will give us 4096. So it's 409694. Let's see. Okay. So I was lucky in that because I did not use the calculator, but if it's a little bit difficult, you can use the calculator for that particular example, and so on. All right, so moving on to the next activity here, we need to calculate the first usable host address, and in that case, the subnet mask is /16 172.18, and then 0, and then this will be 1. The last usable address, let's just put the broadcast first because the broadcast will be easy. So 172.18. Of course, here is 255, and then this one will be the broadcast address minus 1. So it's 172.18, and then minus 1 here in the byte. So it's 255.254. So the next network address will be to take this number and increment it by 1. So it's so in that case it's instead of 18 we have to put 19. And this is 172, and then this will be 0. Let's see, correct.